Oh boy. We are going to do notes on linear and angular velocity today, and it's on your worksheet 39A. On a certain Ferris wheel, one trip around the wheel takes 5 minutes. A long time. One time around. How fast is a rider traveling on this Ferris wheel? There's actually more than one answer to this question. The most intuitive measure of the rate at which the rider is traveling around the wheel is called linear velocity. That's what most of you would think of. Right? The units of linear velocity, this is new. Linear velocity, the units of linear velocity are miles per hour, feet per second, and so forth. Another way to specify how fast the rider's traveling around the circle is angular velocity. Of course, the wheel is a circle. Thank you very much for closing the door. So if we're talking about angular velocity, this is a new concept for us. That's a little bit dark, isn't it? I'll do it green. Okay, and angular velocity is given to be as the amount of central angle through which the rider travels over a given amount of time. So the units for angular velocity in further math classes will be in radians per minute, radians per second, and so forth. The central angle swept out by a rider traveling once around this wheel that took 5 minutes to get around. If he's going around, that's 360 degrees or 2 pi radians. Okay, so if one trip around the wheel takes 5 minutes, then how could we express this rider's travel? So the angular velocity, which is going to be called this Greek letter, and that's read omega. That angular velocity, linear velocity, we're going to be using a v. So v is going to equal our linear velocity. And this new Greek letter omega is your angular velocity. Oops. Not angular velocity. All right, omega would be, for this case, 2 pi radians once around, and it happened in 5 minutes. Now, I realize most of you are going to start calling this W, but I'm going to say omega, okay? 5 pi radians a minute, you may write it like this, 5 pi over 5 radians / minutes, okay, per minute would be on the bottom. And if you were to type this into your calculator, you're going to get 1.26, I believe. It's about 1.3 radians a minute. Pretty rad. All right, so the linear velocity v of a point moving a distance s on the circumference of a circle in some amount of time is given by the following formula. V equals s divided by t. That is linear velocity. You're going to need to know that formula. It is on your reference sheet. Find the linear velocity of a bug stuck on a tire for 5 minutes if a bicycle wheel is traveling 2 miles for a bug. You've got a time of 5 minutes. Oopsie. Another 5-minute venture. This poor bug went 5 miles though. All right, so we got a t of 5 minutes. That's how you dissect the word problem. You've got a distance. What would the distance be? If it's a distance over time that a bicycle wheel is traveling. What letter, though, in the formula? S. Okay, so S equals 2 miles. And so your linear velocity is 2 miles per 5 minutes, or 2, and I'm going to be doing a lot of writing of dimensional analysis because we have to have the labels right. You're going to either divide out the 2 and the 5, or you're going to write 2/5. So the linear velocity is 2/5 of a mile per minute. Oh, let's use MI for miles instead of writing that whole word. 2/5 of a, I just wrote minute. Oh my goodness. A mile per minute, which is approximately 0.4 miles a minute. Okay, that's first example. Now we're going to some more. Number 1, find the linear velocity of a point moving with uniform circular motion. The reason they're saying uniform circular motion, when you ride a bike, do you always go the constant same speed? Well, you must be one special bike rider. I mean, I go slower and faster depending on the incline, and you know what I mean. So we're just assuming a uniform circular motion. Otherwise, this is a little off. Okay, guys, let's get all right. So linear velocity is s divided by t, and that formula can be manipulated. These particular problems, though, are giving us s and t, so we're going to just do it. S divided by t. So that'd be 3/2 of a foot per minute. Or, if you wanted a decimal, 1.5 feet per minute. Okay, so some of these are going to seem pretty easy. The real issue is when you put all the things we're going to look at today together, and then you read a word problem, you've got to be able to decide which formula you need, what you can get, and go back and forth. So it's pretty simple right now. So V is equal to 12 centimeters in 2 seconds. Well, if 12 centimeters happens in 2 seconds, we would, of course, reduce this, bless you, to 6 centimeters per second. Find the distance covered by S by a point moving through a linear velocity of V. Oh, they're giving a V and a T. We want S, so we're going to be using the V equals S divided by T, but we might want to manipulate the formula. So if we are going to find S, what would S equal? It would equal, yeah, T times V, TV. So we're going to put in 45 miles an hour times half an hour. The hours would cancel out, and we would do 45 miles times a half, which would give us half of 45 is 22.5 miles per, oh, just miles. The hours are gone. It's the length. All right, second one. S will equal 63 miles an hour times 10 minutes. Uh-oh. We got a little problem. I can't cancel out hours with minutes. The units must match. That's what you need to realize. Guys? All right, how did you get that, Anthony? Okay. So that would be 1/6 of an hour. So now that I'm multiplying by 1/6 of an hour, you know what? I may want to remind you that in this case, if I wrote it where I really don't like slants for fractions. This is my hours. And I don't know where my 3 went, but there it's back now. Okay, so I have to do 63 miles times 1/6 of an hour, where our hours, of course, cancels out. So 63 times the 6. 63/6, which of course would reduce if I wanted to 31/2. No, excuse me, 21/2. Or, are you getting 10.5? Okay, 10.5 miles. Any problems with how we're getting the answers right now? All right, so let's go on to another type. Angular velocity has to do with how much angle a point P sweeps out over time. Angular velocity is measured in radians per unit of time. Radians a minute, radians a second, radians per hour. And we use omega, where the angle theta must be measured in radians. Here's our formula. Omega equals theta over time, theta in radians. Find the angular velocity of point P. So omega is going to equal the angle in radians is 2 pi over 3 divided by 5 seconds. If you divide by 5 seconds, you would multiply by the reciprocal. So to keep this in exact form, we would need to do 2 pi over 3 times 1/5. Okay. And that is seconds now on the bottom here. You multiply numerator times numerator, denominator times denominator, which would give me 2 pi over 15, and that would be in radians per second. Now, if you happen to divide that out on your calculator, it would be, bless you, 0.42 radians a second. If you do not, if you say you're giving an angular velocity and you don't write RAD, I'm just writing it right now because we're trying to get used to the idea and thinking about what is an angular velocity. Often you won't see RAD in the answer. It's known. It's like, if you don't write it, it's in radians. Okay. So the next one, well, what the heck? I'm just taking theta 24. Oh, you're wondering, wait, that says 24. But does it have a degree sign on it? So it's going to be in radians. Okay, so we're allowed to assume if there's no degree symbol, I am telling you that's radians, because radians don't have to have pi in them. You can have 1 radian, which is, I think I forgot now, 57.9 degrees, and that's that is a radian. You can have 1.5 radians, you can have 20 radians, etc. So this is 24 divided by 6, which would be, let's just do it quick. This is 4 watts, radians per minute. Okay, 7 and 8, it says find the distance S. Well, we've already talked about S before. S is equal to R times theta. We're supposed to already know that formula. You got to know about that one too in today's lesson. So if S is equal to R theta, wait a minute, they're giving me 3 things in this problem. It's saying find S, so I need that. And then it's giving me omega, the radius, and time. This is where the challenge comes in of deciding what to do to get your answer you need. I'll be using the radius in this formula. If I want to know S, I need the radius and theta. Do I have a theta? No. But does omega involve theta in it? And meaning, does omega have to do with theta? It does. Omega is theta over time. So if you want to get omega, you could take and multiply times time times the angular velocity would give you theta. That's what we need to do. So we're going to take time, 5 seconds. We're going to multiply it times omega, 2 radians a second. And that's going to give us theta. Well, I'm looking at the dimensional analysis here. The seconds cancel out. And we end up with 5 times 2 radians, which is 10 radians, and that is our theta. Our final answer, though, is supposed to be about the distance s, arc length. S equals r theta. The radius is 4 inches. So we're going to do 4 inches times 10. And why didn't I write radians? What's the answer going to be in? We don't have anything such thing as inches rads or rad inches, okay? The rads would just drop out, all right? It's the length. This is just 40 inches. I don't know why there's a double W or double omega. I know you guys are going to be saying W, but I'm not. I got the same problem. I have omega, radius, and time, and I want S. So I'm going to have to use my time again. 1 minute. Uh-oh. I have 15 radians a second, and this is 1 minute. I'm thinking it's going to be easiest for us to just convert 1 minute to seconds, don't you? Okay, so let's say that we know 1 minute equals 60 seconds. You've got to pay attention to your labels. All right, so we're going to do 60 seconds times 15 radians a second. And that's going to give us theta. Oh, 60 times 15 is 900. Seconds cancel, so I've got 900 radians for theta. And now S equals the radius 5 feet times 900 radians. And that will give me 4,500 feet. It's very important that we understand that the units in these formulas must be accurate and that all values of theta must first be in radians. So if you are given degrees, you're going to need to multiply any degree measure by pi over 180. Good luck. It's also very important to understand that 1 revolution is 2 pi radians. Remember, 360 degrees is 2 pi radians. I'll work that in, Anthony, since you said 360. So 1 revolution is 2 pi radians. How many radians are in 5 revolutions then? 5 times 2 pi, so it would be 10 pi radians. That is not the distance around unless the circle has a radius of 1. Okay, so this only is a length if the radius is 1, because remember, circumference of a circle is pi times. I don't even want to get into that right now. Anyway, the radius would have to be 1. It's 2 pi r. Okay. Find the angular velocity associated with the given RPM. What's that stand for? Okay, revolutions per minute. I'm going to abbreviate that. 20 revolutions, revs per minute, slash for the per. Means the same thing. I want the angular velocity. So I have to multiply by a conversion factor. We want revolutions to go away because we want it to be in radians a minute. So if I want the revs to go, where am I going to put a revolution? On the bottom. And in 1 revolution, there are 2 pi radians. So with that in mind, canceling out our cross canceling that we can do, revs goes bye-bye. 20 times 2 pi would be 40 pi, and we'd have radians per minute. It is now an angular velocity. That's how you do every one of these. So the next one, 7.2 times 2 pi, and then label it properly, would be 14.4 pi radians per minute. And the last one would be 24,000 pi radians a minute. Okay, we have one more concept to address, which is the relationship between linear and angular velocity. That relationship is the linear velocity. Linear velocity v is equal to the radius times the angular velocity. Angular velocity is in radians over time. The radius equals linear velocity. When you multiply the radians over time times the radius, you get the linear velocity. So we want to know this formula. You will have it on your reference sheet. We got a point is rotating with uniform circular motion on a circle of radius r. Find v if r is 2 inches and omega is 5. So if you're given an r and an omega, you're going to use this v equals r times omega. All right, so the linear velocity is going to be 2 inches times 5 radians a second. And that will give us 2 times 5 would be 10 inches per, drop the rad, 10 inches per second. Same thing for the next one. We're going to do the radius of 3 centimeters. Uh-oh, wait a minute. Nope. What's different? You just don't assume they're all alike. It makes problems. Why am I not? What's going on here? It says find omega. Oh, if r is 3 and v is 8 centimeters. All right, so since we know v equals r times omega, we want omega. What would it be? Wait, v divided by r would equal omega? Okay, or the other way around, as you were saying. Okay, so omega is going to be the linear velocity, 8 centimeters a second. And it's going to be divided by 3 centimeters. Which would make me multiply by the reciprocal of 3 over 1, which would be 1 over 3 centimeters. So my centimeters cancel out. 8 gets divided by 3, and we've got 8/3 of a radian per second. I knew it was an angular velocity, so I added on the rad, but you could even leave it, 8/3 per second would be the same answer. Are we good? All right, so that was all of your notes. Your assignment is, did I forget to do a problem? I did? Oh, hold on. Well, where did I do? Is there another one on that page and I didn't even see it? Oh my goodness, there it is. Find v if r is 1 foot and a point rotates 20 revolutions per minute. All right, so we've got a V. We're going to find V. We have an R. And we want to use V equals R times omega. We got 1 foot, but what's omega? You do. We got to convert 20 revolutions a minute to an angular velocity by multiplying by 2 pi radians for every revolution. All right, so my revolutions goes out. I have 40 pi radians a minute. And that's what I need to plug in here. And I'm just not going to write the rad on there because it's going to go away because we're going to end up, our answer is going to be in feet. So V would be 40 pi, don't forget the pi, feet per minute. Okay, now your assignment is the next worksheet, and the next two. This is 40. You're going to do 40 AB and 41 AB, and I want you to come prepared next week with questions. I'll give you a few hints on this thing. Just note that you're going to go right back to we're using all of the formulas that we've looked at that involve theta in radians. S equals R theta would be the first grouping. This whole first page, you're really using the S equals R theta, and you might want to manipulate that. So if you're given S and theta to find the radius, it would be theta divided by, or S divided by R. S divided by R would give you, excuse me, S divided by, how can I have that? There's an R on both sides. S divided by theta, hello. Area of a sector, remember area formula is 1/2 R squared theta. I'm just laying out a few hints here for the homework. You got arc length and area of a sector for these problems. And then you're going to finally be using the new ones from today at the bottom of the page. If you want to find S, you could find it by doing P times V. All right, that's enough. You figure out what you do on the rest of them.